Let us look at stoichiometry and more concept. To start with, let us define what stoichiometry is. Stoichiometry is just a study of relation between reactants and products of a chemical reaction. Now, to build on this, let us have a look at relative formula mass. So under relative formula mass, we are going to discuss relative atomic mass and also relative molecular mass. Let us look at relative atomic mass. And the first thing we want to do is to define relative atomic mass. Relative atomic mass is just the average of just the average of mass of an atom compared to 1/12 of the carbon 12 atom. So it's just the average of mass of an atom compared to 1/12 of carbon 12 atom. That is what we call relative atomic mass. If we are to look at the element on the periodic table, for example, here we have the first one, which is Ca, which is calcium. If you look at it on the periodic table, in their presentation, you find that on top is a number and at the bottom here. So the top number is called the mass number and the bottom number is called the atomic number. To find or to identify the relative atomic mass of calcium in this calcium here, you just pick this top number. So in other words, the top number always with the elements that are on the periodic table, the top number is what we call the atomic mass of an element. Then also magnesium, 24 is the atomic mass. Okay. So that is what we need to know on atomic mass. So there's nothing really to calculate. You just have to pick these numbers on the periodic table given the element. So just pick the top number, that is the atomic mass. Okay, I guess there's no problem on this particular part. Let us have a look at the second part that we can look at under relative formula mass, and that is relative molecular mass. Let us have a look at relative molecular mass. And let us define the relative molecular mass first as well. So it's just the sum of all the relative atomic masses in the molecule or compound. So this time around, you are dealing with a molecule or a compound. And in this case, you're going to add all the relative atomic masses in the molecule or compound. And please, this is where even exams start from. You might find the question, find the relative formula mass or molecular mass of the compound when you are given the compound, as we are going to see here on the examples. So let us look at the examples. Find the relative molecular mass of, the first one is carbon dioxide. So carbon dioxide is CO2. How do you find the relative formula mass? Remember, relative formula mass is just the sum of relative atomic masses in the molecule or compound. So the first thing that you can do is to identify the atoms that are in that particular compound or molecule that you're given. So in this case, carbon dioxide, what are atoms that are found in carbon dioxide? Let us not consider the numbers first, but the first part, we are just identify them. So we have oxygen, so you can put a line like that. Then you also have carbon. Now you can go to the numbers. Okay, how many of oxygen do we have? We have 2. Multiply. What is the atomic mass of oxygen? If you look at oxygen on the periodic table is O, then on top you're going to find 16. So that is the number that you pick. So there are 2 of oxygens here. So since one is 16, you multiply by 2, and this you are going to have 32. Then carbon, if you look at the periodic table, carbon is just C, on top there's 12. So for carbon is 12, but just have 1 carbon. So 1 multiplied by 12 equal to 12. So if you add this, you're going to find 44, I guess. So 44 is relative molecular mass of carbon dioxide. So that is just what you do. Now, I'm not saying that you have to go through all this, or what you can do is just putting these in brackets, whichever way that you do it, but you need to take into account the number of atoms, and of course, if they are more than one, you need to multiply with that number that is there so that you can find the actual value. So that is how you basically find the relative molecular mass given a compound or a molecule. The second part is calcium carbonate. Let us look at calcium carbonate. So calcium carbonate is CaO3. Remember the first part, we need to identify the atoms. So here what you have is oxygen. And how many of oxygen? 3. So 3 multiplied by 16. Then we have carbon. How many of carbon? 1 multiplied by 12. Then you have calcium. This is not carbon and whatever is there, but you need to know that this symbol is for calcium. So calcium is just 1 multiplied by 1 calcium is 40. If we are to add these, that is, before we add, we multiply. 3 multiplied by 16, that is 48. 48 plus 12, that is 60. 60 plus 40, that is 100. So the relative molecular mass of calcium carbonate is 100. And there are no units for these. All right. So we've looked at for 2. And I guess you are able to, you are following and you understand what we are doing so far. Okay. Then now, let me give you this one. So this is example number 3, that is C, on relative molecular mass, sodium sulfate. Now, sodium sulfate is already given here, which is Na2SO4. So you find the relative molecular mass of sodium sulfate. Be able to post your answer in the comment section, and also we'll be able to learn from you. Okay, so this one I leave it up to you. All right. Now that we've looked at relative formula mass or relative molecular mass, let us have a look at the mole. So this is another sub part that we've started, which is the mole. The first question that we are answering, as usual, we go for the definition. So let us answer a question, what is a mole? And this is a viable question that comes in an exam in a particular year, should be 2023. I think the opening question was, what is a mole? That is on the question for mole concept. So to define a mole, we are going to say a mole is just an amount of substance which contain as many elementary particles or entities as they are in 12 grams of carbon-12 isotope. That is how you simply define a mole. The amount of substances which contain as many elementary entities or particles as they are in 12 grams of carbon-12 isotope. Now, what are the units for the mole? So the mole is just a unit, of measurement. So the unit for mole, the word mole, you write it like this, but for the unit, you just write MOL. That is the unit. Now, there's something that I've mentioned in the definition, that is particles. So now, this part, you need to take it and you need to know it very well. That 1 mole of any substance, no matter the amount, no matter the state, it is what? It is equal to, or it contains 6.023 multiplied 10 to the power 23 particles. 1 mole of any substance contain 6.023 multiplied by 10 to the power 23 particles. Now, particles can be atoms, molecules, and ions. In the calculations, they will specify, okay? They can talk of atoms, molecules, or ions, but not 2 at once. So, don't worry about the calculation. How do you know that you're finding ions? How do you know that you're finding atoms? How do you know that you're finding molecules? Instead, the questions will specify, okay, how you work out this one. So that is very important to understand. Okay. Having looked at this information, let us now look at the calculations. So with what we've learned so far, that is what we are going to base our calculations on. So, and I hope up to this point you understand, or you have some information that we can use as the prerequisite information in as much as, or in as we enter into the part for calculations. All right, so calculating number of moles. That is the first part that we are going to, that is the part that we are looking at. Calculating number of moles. I should admit that there are different methods and different formulas that you can use to calculate number of moles. But in this one, we are going to learn about 4 formulas. So that we are going to use in calculating number of moles, and of course in different situations or different scenarios that will be given. So let us look at these parts. So the first part that we are going to look at is calculating number of moles when you are given what? Number of particles. So that is the first part that we are going to handle. Calculating number of moles when you are given number of particles. So take note of this part. Now, the formula that we use is n, small letter n, please represent number of moles. Capital letter, this is n, just on top is number of particles, and this at the bottom n with a subscript a, that is capital letter A written as this. That is the Avogadro's constant, and this number is experimental, so it is always there. You need just to master it, which is this number here. Okay, so that is what you use to calculate the number of moles. Let us look at an example. Find the number of moles in 3.0 multiplied by 10 to the power 23 atoms. So like I said, they will specify what you're calculating. Are you dealing with atoms? Are you dealing with particles? What are you dealing with? So they'll always specify what you are dealing with. So calculating number of moles given the particles. So what do you do? So in this case, you are going to say number of moles is equals to, you start by writing the whole of that is this part. Then you replace. So 3.0 multiplied by 10 to the power 20 divide by 6.023 multiplied by 10 to the power 23. The number that you find here, that is your answer. Now, when dividing, you have to make sure that you punch the calculator correctly. What do I mean? If you are going to punch it direct like this, just a number, then divide this, is not going to give you the accurate answer. Instead, you want to put this in brackets, then divide, then open brackets, then of course you punch in that whole number. Now, what do you find after you are done with that? So when you punch here, the answer that we find is 4.98 multiplied by 10 to the power negative 4. Okay, we are finding number of moles, so more. So please be able to confirm this answer if that is what you are getting as well. So as we go through, or even as you go through the recording, make sure that you also have a notebook that you are using to take note of the questions. You can even solve before I even solve the question, so that you compare at the end. Just still on the same part, the second part that we are looking at, that is the B, which is the second question. That is the second example. Find the number of atoms in 2 moles of potassium. So if you look at this formula, here what you have, you can calculate the number of moles and also the number of particles given the number of moles. Okay, the Avogadro's constant, it is always there. So which means sometimes you might find the question where you're asked to calculate the number of particles. In this case, the particles that you're calculating are atoms. Okay, so atoms are the ones that you're calculating. So what are you going to do? You make n, which is number of particles, the subject, and you're going to have number of moles multiplied by the Avogadro's constant. So in this case, you just replace number of moles. What is the number of moles? 2 moles. Multiplied by the constant is 0.23 multiplied by 10 to the power 23. That is the atoms, okay, per mole. So more and more cancels, then it's just the same as 2 multiplied by 6. Okay, 2 multiplied by 6.023 multiply 10 to the power 23. And if you multiply this, you should be able to find after you multiply this, you should be able to find 1.20 multiplied by 10 to the power 24. That is the atoms. So this is how you can find also number of atoms using the same formula. Let us have a look at the third question, or the third example. Find the number of molecules in 3 grams of carbon dioxide. Find the number of molecules. Now, molecules is just the same as also find the number of particles. So to find the number of particles, we are just from doing so. So you multiply number of moles multiplied by the what? The constant. This time around, just that we have molecules. Now, you know that a constant is already there, which is 6.023 multiplied by 10 to the power 23. But we have number of moles? No, we do not have. But what are we given as the information? We are given 3 grams of carbon dioxide. Now, let me bring in another formula for calculating number of moles, something that we are going to discuss soon. But for the sake of this question, let me just bring it here. So number of moles is equals to mass over molar mass, which is given mass over molar mass. Okay, so molar mass is just the number of, the mass of 1 mole of a substance. Okay, that is the molar mass. So now, that is what we are going to start first by doing. We are going to start first by calculating number of moles. Given mass, in this case, is 3 grams. Then molar mass, we just find the relative formula mass of carbon dioxide, which we will have found at some point to be 44. Then the units of molar mass is gram per mole. So when you divide 3 divide 44, what are you able to find as the answer? Let us just divide. Okay, so divide as well. 3 divide 44. Okay, so for me, I'm finding 0.068. I don't know if that is what you found. I'm finding 0. Oh, let me just replace first. So number of particles we have, okay, we are not yet there. So 0.068, that is what I've found. What have you found? Can you just confirm? So if you find this one wrong, which means even the answer will be wrong. So now we can bring it here now and say 0.068 multiplied by, that is 6.023 multiplied by 10 to the power 23. And what are we able to find? I can put the units here in advance, molecule or molecules. So let me just multiply this number that I've found with it. So multiply 6.023 multiply 10 to the power 23. And I hope you know how to operate the calculator. So for this one, it is giving me to the power 22. So 4.11 multiplied by 10 to the power 22 molecules. So that is what it is giving me. So what is the lesson that we can learn here? It is that when you want to find number of molecules, atoms and ions, just know that these are particles. So you are finding number of particles. And if you don't have given number of moles, you need to start by finding number of moles. And to find number of moles, so far we've looked at using number of particles and the constant. So let us have a look at other ways to calculate number of moles, and I hope by the end you'll be clear on things to do with calculating number of moles. So which means the other part that we can look at, which is the second part, calculating number of moles, remember that is the part that we are looking at. So the second scenario that we can look at is when we are given mass. So calculating number of moles with a given mass. So the example that we can look at here is calculate the number of moles in 60 gram of carbon. So the formula, as you can see, it is this one. The top part is given mass, then the down part is the molar mass. Okay, molar mass. So now, number of moles is equals to given mass over molar mass. Now, the given mass is 60 gram, divide. The molar mass, we are talking of the molar mass of carbon. Okay, so the carbon on the periodic table is C. Then on top there's a 12 there. So this is the relative atomic mass, but you give the units of gram per mole, making it the molar mass. As you know, the molar mass is just the mass of 1 mole of a substance, in this case carbon. So it is 12 gram per mole. So now if you cancel out this, that is 60 divide 12, you are going to find 5 mole. So the number of moles here is 5 mole. So that is how you find the number of moles given the mass. Okay. Then the second part, if you look at the formula, number of moles is equal to given mass over molar mass. So here you can also find the mass. You can also be asked to find the mass given the number of moles and you know the element or the compound being mentioned here. So you can find its molar mass and multiply them. So to find the mass, we can say mass is equals to number of moles multiplied by the molar mass. Let us look at this example that we have. So find the mass of 2 moles of calcium. So the number of moles is given, which is 2, and calcium, we can find its molar mass. Okay, so number of moles is 2 mole, then multiply by calcium, the molar mass. If you look at calcium on the periodic table Ca, on top there is 40. So 40 gram per mole. Okay, so that is the mole and mole cancels. Then you are remaining with 2 multiply 40 gram, that is 80 gram. So the mass here of calcium given 2 moles of it, that is 80 gram. So that is the way you find the number of moles. That is the way you find the mass given this formula. So please, I've talked of 2 ways you use this formula, and I guess there's no problem up to this point. Can we proceed now to look at the third one? Like I said, we are going to look at about 4 of them. So this was the second one. Let us look at the third one. So finding number of moles still. This time around, when you are given the gas volume. Now the volume of the gas is it at a certain condition. That is called molar gas volume. So the volume of a gas can only be measured at a certain condition. So this time around, the formula is number of moles is equals to V over Vm. V is a given volume, just like in the given mass. So V is a given volume. It can be in cubic centimeter or decimeter. Okay, we are going to use that there. We are going to look at how you calculate the number of moles in both cases. Okay. Then Vm is molar gas volume. Molar gas volume is just the volume occupied by 1 mole of every gas at a certain condition. So 2 of the conditions that we are going to look at, one of them is room temperature and pressure. And we need to know the volume of the gas at room temperature and pressure, the Vm. And also the volume of the gas at room and at standard temperature and pressure. Okay, so the Vm at standard temperature and pressure. So here we know that 1 mole, or we should know that 1 mole of a gas at RTP. RTP stands for room temperature and pressure, but I think it's always given in words where you understand. So the volume of the gas in decimeter cubic, it is 24. But in centimeter cubic, you know that centimeter is less than decimeter, and 1,000 of 1 decimeter cubic is equals to 1,000 of centimeter cubic. So in terms of centimeter cubic, this one is 24,000. So whichever, if you use the volume, we are going to see that anyway. So 24 decimeter, that is at room temperature and pressure, or 24,000 centimeter cubic. 1 mole of a gas at STP, standard temperature and pressure, it is 22.4 decimeter cubic. That is in decimeter cubic. In centimeter cubic or cubic centimeter is 2,400. Okay, centimeter cubic. Okay, or cubic centimeter. That is it in centimeter cubic, or cubic centimeter rather. Let us look at the examples. Calculate the number of moles of hydrogen gas in 250 cubic centimeter at room temperature and pressure. So like I said, the condition will always be specified. So what is important is to look at how you use the formula. So the formula that we have is number of moles is equal to the given volume, then divide Vm. So Vm will always be given. The condition immediately they give you, just pick the Vm. But they will not give you but you need to know that at STP is 22.4 decimeter cubic, and also that is 24 decimeter cubic. You need to know that. Okay, so what are we given as a volume? So the volume we are given as 250 centimeter or cubic centimeter. Now, immediately you see this, you cannot use the volume in decimeter of a gas at room temperature. Okay, so we cannot use VM at 24 decimeter cubic. Instead, we have to use also the one that is in centimeter. So you're going to use 24,000 centimeter cubic. And if you divide this, it's just say this is per mole. Is that you cancelling out? So 1 0 gone, 1 0 gone. So it's just the same as the 25 divide 2,400 or 250. 250 divide 24,000. What is the answer? Okay, so the answer that I'm finding right here is 0.01. Okay, 0.0104. Yeah, I think we can leave it there. Okay, 0.0104. That is the more. Okay, so confirm what you are able to find. But if you want, you can use it in decimeter, where you say you just convert this 250 into decimeter by dividing it with 1,000. And I guess this one should be able to give you 0.250 divide 24 decimeter cubic per mole. This is the decimeter cubic. You should be able to find the same answer. So someone to confirm that you should be able to find the same answer. Let me start by dividing 250 divide 1,000. Let's see if it will give me. Okay, 0.25. Then divide 24. Okay, should be able to give us the same. So that is how you can use this one. And these are very important when it comes to calculations. You are going to see how to apply them as when you are given a full question. So take note of this part. All right, so the fourth part, or the formula number 4 that we can look at in terms of calculating number of moles, we can look at when you are given concentration. So this is the part when you are given concentration. Now, we are going to take an opportunity also to cover the part for concentration, because there's nothing much here to look at. So concentration is just the amount of solute dissolved in a unit volume of the solution. That is what we call concentration. So at some point, we are going to look at also some dilution and all that. But for a moment, since we are looking at calculating number of moles, we can just look at this on the surface. So concentration is the amount of solute dissolved in a unit volume of the solution. The SI unit of concentration, I've seen a question where you're asked to define concentration first in an exam. So this is one of the possible question, and also giving the units of concentration. So now concentration, the units can be gram per decimeter cubic, which means the amount of solute per decimeter cubic of a volume. Also in moles per decimeter cubic. And this one has a special name of morality, otherwise abbreviated as just capital letter M. So sometimes in the questions, when you find capital letter M in front of the number, just know that that is morality and the unit is mole per decimeter cubic. In the case, you need to consider some calculations. But if you give grams per decimeter cubic or mole per decimeter cubic, the units of concentration is still okay. Let us have a look at the question. So find the number of moles of sodium hydroxide in 500 cubic centimeter of 2.0 mole per decimeter cubic. So what are we finding? Number of moles. And from the formula there, number of moles is equals to concentration multiplied by volume. Now you need to know that the volume should always be in decimeter cubic for you to find number of moles. Take note of this. Take note of this. The volume should always be in decimeter cubic. So what you do, the volume that you are given in cubic centimeter, you just divide it by 1,000, and in this case we are going to have 0.5 decimeter cubic. So that is the one that we can multiply now. So we can say, since concentration is 2, so 2 multiplied by 0.5, and this, you know, that is more. So 2 multiplied 0.5 is just half of 2, which is 1. So the answer here is 1 more. Okay, so take note of this, very important. Okay, so that is how we calculate number of moles. We've looked at the 4 formula, and of course you should be able by now to calculate the number of moles given the number of particles, given the mass, given the volume and the condition, also given the concentration. So these 4 parts are very important. I think that is where more concept is centered on, and that is where most find it challenging, more especially when it comes to picking which formula that you are going to use. And very important to understand also the information that you are given. And in all the calculations, I hope you followed the steps that you followed, because most of you have a tendency of just starting calculating from anywhere and going nowhere. So you need to start first by putting up the formula, then you replace, then the final answer. I think these 3 steps are very important because most of these questions are 2 marks questions. Okay, I guess you understand that part. Let us now look at calculating number of moles from the balanced chemical equation. So that is one of the part that we are going to look at, not using the formulas but from the equation. And this is where now you need to learn how to formulate the chemical equation. And there is a video on chemical equation and how to write and balancing all that. You cannot calculate here without the equation and without balancing it. So let us look at it. And to start with, you are going to introduce this question: how many moles of chlorine are required to react with 2.5 moles of calcium to produce calcium chloride? So here, we are not just going to go direct into calculating. The first part, we put up the chemical equation of the reaction here. And as you can see here, what is reacting is, chlorine are required to react with calcium to produce calcium chloride. So what is reacting is calcium reacting with the chlorine. Chlorine is a diatomic, so you do not write it as just Cl. So you write it as the C2. Okay, it's a non-metal also. You can take note of that. Then what is going to come out is the calcium chloride. Now calcium has a valence of 2 and chlorine has a valence of 1. When these react, it's going to form calcium chloride. So this is the product that is going to form. Okay. Then now, what are we going to do? We check the atoms on both sides and they should be same and of course balanced. So here in front we have calcium 1, then calcium chloride 1. So on the other side you have calcium 1, also here calcium 1, chlorine 2. So this equation itself is balanced. So now what we are asked is how many moles of chlorine. So you form up or you come up with a ratio. So this calculation that we are going to perform here, it is called mole to mole ratio. So we are going to form mole to mole ratio. Look at what is being mentioned. How many moles of chlorine? So chlorine should be part of the what? Should be part of the ratio. Then are required to react with 2.5 moles of calcium. So which means also calcium. So you are forming the ratio of calcium and chlorine. Now, from the equation, the balanced equation, 1 mole, in short, the numbers in front of these reactants or products, you treat them as moles or number of moles. So there's a 1 in front of calcium. If there was a 2 here to balance, we would have written 2, but it's 1. Okay, so 1 mole of calcium, in this case, react with 1 mole of chlorine. Okay, then we have the given 2.5 moles of calcium. How many moles of choline will it react with? So that is the ratio that we form. So 1 mole of choline react with 1 mole of 1 mole of calcium react with 1 mole of choline. What about 2.5 moles of calcium? Okay, react with what? So in this case, react with what? 2.5. So you cross multiply here. It's just the same as x is equals to 2.5 mole multiplied by 1 mole, then divide 1 mole. And the resulting answer is 2.5 mole, as you can see. And why has it tend to be 2.5 mole? Because this is a 1-to-1 ratio, and therefore the number of moles of choline reacting is equal to the number of moles of what? Calcium. So that is how you basically use the mole to mole ratio to find the number of moles. Let us build on this one, and maybe we have a different question this time around, okay, that have different ratios in other words. So the second example is how many moles of carbon dioxide? So the equation is already written here. So how many moles of carbon dioxide will be produced by complete combustion of 2 moles of glucose, which is this one, according to the equation. So in this case, the equation is given, but not always that the equation is given. But we are lucky that it's given and it's balanced. If you were to check. So how many moles of carbon dioxide? So you form a ratio. So the ratio that you are going to form is the carbon dioxide, then 2, okay, produced by complete combustion of 2 moles of glucose. So glucose is C6H12, O6. So now in front of carbon dioxide there's a 6. In front here there's just a 1. So what this means is that 1 mole of glucose this time around react with oxygen to produce 6 moles of carbon dioxide. What about 2 moles of glucose? As you can see here, what amount of carbon dioxide will be produced? So X is equals to 6 mole multiplied by 2 mole, then divide 1 mole. In other words, it's just a double the number of moles. So it will be 12 moles of what? Of, you can even indicate, of carbon dioxide will be produced. Okay, so that is how you use mole to mole, and I hope you've picked something here. All right, so aside from this part, let us also build on something, because at times you'll be asked to find the mass. Okay, so from the equation, how do you find the mass? So one way you find the mass is using what we call mass, that is mole to mass. How does it work? So let us look at an example. What mass of sodium chloride can be produced by reacting 6 moles of sodium hydroxide with hydrochloric acid? So what we want to find is the number of moles of sodium chloride. Chloride, yeah. So sodium chloride is written as this. Then what are we looking at here? What are we given? We are given that of sodium hydroxide. Okay? Sodium hydroxide. So in this case, we have sodium hydroxide to sodium chloride. Now, if we are to write the balanced equation here, that is one thing I forgot to mention, because we are using mole to mass. So we write the balanced chemical equation, that is sodium hydroxide reacting with hydrochloric acid, which is HCl, and all these you need to know how to write. Okay, then what are you going to form? Sodium chloride and water. This is a neutralization reaction, or a reaction that involves a base and an acid and result into a salt and water. So let us look at if this equation is balanced. Take into account what we have. Sodium we have 1, sodium 1. Oxygen we have 1, oxygen 1. Hydrogen 2, hydrogen also the other side 2. Chlorine 1, chlorine 1. So this equation itself is balanced. So it's also a 1-to-1 reaction. So this one, you know that the number of moles of sodium hydroxide equal to the number of moles of what? Sodium chloride. So let us do it. 1 mole of what? Sodium hydroxide react with HCl to produce 1 mole of sodium chloride. What about 2 moles of sodium hydroxide? How much of sodium chloride will be produced? We don't know. So this one we can say X is equals to, you know, that's just multiply 2 multiplied by 1 divide 1, which is just the 2 moles as well. Is it 2? This one was supposed to be 6. So which means it's 6 moles as well. Okay. So that is how we find it. So 6 moles of, you can write 6 moles of sodium hydroxide. So that is how we use, no. We are not supposed to do that. We are finding the mass. So this one, please, we can just reserve it for the sake of finding number of moles of the other one. But what about the number of, the mass? So look at this one. We found the number of moles using mole to mole ratio, which is 6 moles. Then now finding the mass, if you're asked to finding the mass, you can say mass is equals to number of moles multiplied by the molar mass. Number of moles is 6 multiplied by, these are number of moles of sodium chloride. So 6 multiplied by what? 6 multiplied by, what is the formula mass of sodium chloride? We have sodium and chlorine. Sodium, you know that is 23. Then plus chlorine, you know that is 35.5. If you add these, you're going to find 58.5. So multiply 58.5. Whatever you find is the mass of sodium chloride. Okay? What are you able to find? 6 multiply 58.5. So we are able to find 351. 351. Let us see, even using the mass to mole to mass, if you are going to find 351 gram. So now mass to mole to mass works that 1 mole of, from the equation please, 1 mole, let me just rewrite it, this one, maybe it will make sense. I guess I haven't lost anyone. So we have sodium chloride, sodium hydroxide to sodium chloride. So 1 mole of this, how much of this one is produced? So you find, now this one, if you are using mole to mass, you say 1 mole, the first one you consider the number in front in terms of moles. But for the second one, you find its molar mass, then you treat it as relative formula mass and treat it as mass. So 3, this one is 58.5. That is the molar mass of the whole of this one. So we say grams. Then what about 6 moles? How much is it going to be? So which is just the same as X is equals to 6 multiplied by 58.5 divide 1, which is just something that we found to be 351. I guess no one is lost here. So that is how you use mole to mass. Mole to mole works, but you have to use the formula for number of moles is equals to given mass over molar mass, or mass is equals to number of moles multiplied by molar mass. That is to find it. But for this one, you just go, you cross multiply and all that. Okay, so I guess you've understood that part. Let us look at now mole to mole. Oh, for mole to mole, we've already looked at it. So for mole to mole, we've already looked at it, but we can just do this as the way of concluding the part. So how many moles of calcium, or carbon dioxide, will be produced by complete combustion of 3 moles of glucose? So I think this part, we've done it at some point, though it was, I think it was different one. Did we have the question which has to do with moles of, yeah, I think we did such a question. But anyway, so for this one, we are going to say the equation is already here and balanced as well. So how many moles of carbon dioxide? So we have a ratio of carbon dioxide will be produced by complete combustion 3 moles of glucose. So we have glucose also. So it is glucose to carbon dioxide. They are saying, so from here, the balance equation, in front of carbon dioxide, we have a 6. So 1 mole of glucose undergo combustion to produce 6 moles of carbon dioxide. What about 3 moles of glucose? How much of carbon dioxide will it produce? So in this case, you have x is equals to 3 multiplied by 6 divide 1, which is just the same as 18 mole. So if I'm not mistaken, so 18 moles of carbon dioxide. Okay, so that is how you basically look at this. So please, we've come to the end of lesson 1. That is under more concept, and I guess you've enjoyed the lesson. If you've done so, please do not forget to subscribe and also to share the video with others. Otherwise, we also offer intensive online lessons. If you are interested to join us, you can contact the number 0976 402563. We'll be waiting to have you in class and to prepare you for the exams. Otherwise, we can end here and see you in the next one.